Dynamics is a crucial area of physics and engineering that deals with the motion of objects and the forces affecting that motion. This presentation will cover fundamental principles of dynamics, applications in various fields, and the distinctions between kinematics and dynamics. We will explore the fundamentals of dynamics, including definitions and key concepts such as Newton's laws of motion. Next, we'll differentiate between kinematics and dynamics and their real-world applications. We will also discuss forces, motion, energy, work, power, and the applications of dynamics in engineering. Understanding the fundamentals of dynamics is essential for grasping how objects move and interact. This section will introduce key principles that form the foundation of dynamics as a discipline. Dynamics is the branch of mechanics that deals with the study of forces and their effect on motion. It encompasses the analysis of forces acting on bodies and how these forces influence their movement. Sir Isaac Newton formulated 3 fundamental laws of motion that describe the relationship between a body and the forces acting on it. These laws are essential for understanding the principles of dynamics. Newton's first law states that an object in motion stays in motion unless acted upon by a force. The second law states that the force acting on an object is equal to the mass of that object multiplied by its acceleration. Newton's third law states that for every action, there is an equal and opposite reaction, illustrating the interaction of forces. In dynamics, force, mass, and acceleration are the key concepts. Force is defined as any interaction that alters the motion of an object. It can be applied in various forms, such as push or pull. Mass refers to the quantity of matter contained in an object, which also affects its resistance to acceleration. And acceleration is the rate of change of velocity of an object, indicating how quickly an object speeds up or slows down. It is important to differentiate between kinematics and dynamics, as they describe different aspects of motion. Kinematics focuses on the description of motion, while dynamics relates to the forces that cause that motion. Kinematics focuses on the motion of objects without considering the forces that cause this motion. Displacement measures the change in position of an object and is a key concept in kinematics. Velocity indicates how fast an object moves in a specific direction, while acceleration measures the change in velocity over time. The key difference between kinematics and dynamics lies in their focus. Kinematics describes the motion itself, while dynamics explains the forces and their effects on that motion. Both kinematics and dynamics have practical applications in various fields. Kinematics and dynamics are critical in robotics, allowing for precise movement and control of robotic systems. Understanding motion and forces is essential in transportation for designing efficient vehicles and traffic systems. In sports science, kinematics and dynamics help analyze athletic performance and improve techniques for better results. Forces play a crucial role in dynamics, influencing how objects move and interact. This section will explore the different types of forces and their effects on motion. Forces can be categorized into 2 main types: contact forces and field forces. Contact forces occur due to physical interactions between 2 or more objects, such as friction, tension, and normal force. Field forces operate at a distance without physical contact, including gravitational and electromagnetic forces that affect objects over a distance. Analyzing motion requires understanding how different forces affect objects. This includes studying cases of uniform motion, accelerated motion, and the impact of net forces. Uniform motion occurs when an object travels in a straight line at a constant speed without changing direction. Accelerated motion involves changes in velocity, which can occur due to various forces acting on the object over time. The net forces acting on an object determine its motion, whether it remains at rest or accelerates in a specific direction. An object is in equilibrium when the net force acting on it is 0, resulting in a stable state. Non-equilibrium states occur when unbalanced forces act on an object, resulting in acceleration or change in motion. Energy, work, and power are interconnected concepts in dynamics. Understanding these relationships is essential for analyzing motion and the forces involved. Energy is the ability to perform work or cause change in a system. Energy can be classified into several forms, including kinetic, potential, thermal, and mechanical energy, each with unique characteristics. Kinetic energy is the energy of motion, depending on the mass and velocity of an object in motion. Potential energy is stored energy based on an object's position or condition, like a raised weight or a compressed spring. Thermal energy is associated with the temperature of an object and the motion of its particles, contributing to heat transfer. The work energy theorem states that the work done on an object is equal to the change in its kinetic energy. This principle helps connect the concepts of work and energy. This theorem helps to understand how the work done on an object affects its kinetic energy. Power is the rate at which work is done or energy is transferred. It can be calculated by dividing the amount of work done by the time taken to do that work. Dynamics plays a vital role in various engineering disciplines. Understanding how forces in motion interact is essential for designing effective systems. In mechanical engineering, dynamics is crucial for analyzing forces in structures and mechanisms, ensuring safety and functionality in design. Dynamics is fundamental in automotive engineering, affecting vehicle design, safety, performance, and fuel efficiency. Engineers leverage dynamics to enhance vehicle design, ensuring safety and improving fuel efficiency while maintaining performance. By applying principles of dynamics, engineers aim to optimize vehicle handling and passenger comfort for a better driving experience. In aerospace and aeronautical engineering, dynamics is essential for analyzing the behavior of aircraft and spacecraft during flight. Flight mechanics encompasses the principles governing the motion of aircraft and spacecraft, ensuring optimal performance and safety. Ensuring stability and control in flight is vital for the safe operation of all aircraft and spacecraft. Dynamics is a foundational principle in both physics and engineering that governs the motion of objects and the forces acting upon them. A solid understanding of these concepts is crucial for advancements in technology and engineering applications.